Hey, welcome back to the quadratic function part 4, and this is the first presentation where I'm going to take away your fear or that your calculator won't be able to help you out. I have flat batteries, mate, and what we're going to do is to come up here to solving equations. We're going to do the first of the things that I suggested to you in that last presentation about if the quadratic function is in this form, can you find where it cuts the x-axis, even if your batteries are flat? And let's have a look at how you do that along the x-axis. Y is naught, as we said before. So you're trying to solve this equation. Let's get into it so that we don't need that calculator. We'll use mathematics, mate. Let's come down and have a look. And I've got 3 here that we're trying to find where these functions cut the x-axis, because we're putting the function equal to naught. In other words, if we call the function y equals this thing here, this would be equivalent to where that function was cutting the x-axis. That's the context that I want to put this in. Pearson's and other textbooks quite often give students just equations and ask them to solve them. I want to link it to a context, like if we're drawing the graph of this quadratic and your batteries are flat, you can still do it. You can find where it cuts the x-axis or y-axis, find the turning point, and do everything you need to really nail the graph of this function. Right, so that's what we're up against. What are we going to do then? Here's a hint. Here's a hint. I'm not sure whether you can do this, because the hint is, can you factorize these expressions? What that means is write this expression as a product of 2 factors. Something, and maybe a bracket, times something else. For this one, can you factorize it? Hey, you might not have even seen that before, so we might investigate it. But why do you want to factorize it? Let's investigate all that stuff. So coming down here, did you get these answers? Well, only if you remembered something about expansions, because factorization is the opposite, isn't it? Factorize implies what? Reverse the expansion of brackets. Can you see that? Let's do it right now. Can you see that x squared take 1 would have come out from the rule a plus b by a take b is a squared take b squared? Do you remember that? And now it could be useful, because I'm going to call x squared take 1 x plus 1 by x take 1. And I've been able to write it as a product of factors. You still don't know why we want to do that, but believe me, it's going to help us a lot. And x squared take 2, you could think of that as x outside of a bracket. X, what would you multiply x by to get x squared? You need an x in there, and then x by neg 2. So we can package that backwards using the reverse ideas of expansion and all that stuff. So now, our equation, instead of being x squared take 1 equals naught, it becomes x plus 1 by x take 1. We're replacing x squared take 1 by a factored form. A factored form. All right, and you might say, well, why bother, Huddy? What are we doing here? Why bother with writing both of them like that instead of the original? Well, I've got something for you here with a really special rule in mathematics. And here's the answer to your burning question. Haven't written this one in red, mate. Why might it be easier to solve the equations in this factored form? Because we can use, in red, the hot stuff, Null Factor Law. If we are told 2 things times give 0, then that implies that one of them must be 0. I guess you always knew that. But if I say x times 2 comes to nothing, the only way is that x is 0 itself. Hey, the Null Factor Law says that if you have a product of factors equal to 0, then one of those factors must be null, or nothing itself. So if you have 2 things times give 0, and you can call these 2 things times factors, because let's go to the definition of factors, are numbers multiplied together, aren't they? To give the original number. Numbers multiplied to equal the original number. That's not an original expression. Expressions just stand for numbers in algebra land anyway. So the null factor law of two things at times are two factors give the product of 0, then one of them must be null or nothing. A or B must be 0. You can't make a product come to nothing unless one of the items or factors in it is nothing. And of course here it is. Factorization is the process of writing an expression as a product of its factors. You've seen this before. What are the factors of 6? 3 and 2, because 3 times 2 is 6. What are the factors? Oh, also 6 and 1 are factors, because 6 is 6 times 1. So there might be some value now in solving our quadratic equations if we can write them as a product of factors, and then with a null factor law up here we can say one of those factors must be 0. Let's do it now and have a look. So here's our original question. X plus 1 by x take 1 is 0. Well, that's not true, honey. X squared take 1 was 0. And then that implies, not a bad symbol to use to lead on in an equation to the next line, that implies x plus 1 by x take 1 is 0. Why is this a terrific form? Because now we have, let's just get rid of this, we have either, there's two factors there, that times that, so either x plus 1 is 0 or x take 1 is 0 by the null factor law. NFL, nothing to do with football, mate. Anyway, so here x is neg 1 or x is plus 1. What was the point of that? Let's have a look at it graphically. Let's link it to what we were doing. Let's have some fun. X squared looks like this. X squared take 1 looks like this. Doesn't it? We go down the axis. Hey, what have we found? We just put the graph of y equals x squared take 1 equal to 0. That means we've found the exact points where it cuts the x-axis. I told you wouldn't need a calculator. All that worry about your batteries being flat was unfounded, mate. We can do this. This is the point neg 1 0, and this is the point 1 0. Hey, how powerful is that? Well, let's keep getting excited. What was this function here? This function here was x squared take 2x, and we put this function equal to 0, and we said if we factorise it, we get that. Two factors, x times x take 2, check it by expansion, then one of those two factors must be 0. Either that is 0, so here x is 0 or x is 2. Two possible values. How does it help us in quadratic land? Well, let's draw the graph of y equals x squared take 2x. Oh, this is hard. Why don't we use what we've just found? I don't know what that looks like because it's not in an easy form, but we know it's x-intercepts. X is 0 there, and x is 2 here. So, what do we reckon? We'll go like this. It would be nice to find the vertex, wouldn't it? You're going to have to wait until the next presentation for that. We're going to nail this function without technology. Hey, think of all the battery money it's going to save you, mate. Oh, okay, let's keep going. Let's have a look. Here's a challenge. If you remember, back at the beginning of this presentation, I lined up 3 functions, and the last one was this one here, x squared plus 5x plus 6. How are we going to package that up? Well, I've cheated a little bit. I've put the answer here. And do you remember your expansion words, methods or work? FOIL. First, outers, inside terms, last terms, and then add them up. Let's check it. Am I right? X by x gives x squared. X by 2 will give 2x. Then 3 by x, it's working, 3x, and then 3 by 2 is 6. Hey, if you could work backwards from FOIL, working backwards, you could do factorizing. Factorize it. And look at what's going to happen. Let's go over here with this quadratic function. It's this one. And we would have an awful hard job of graphing that without a calculator unless we did this. Let's put this function equal to 0 and opposite to foiling. Let's work it backwards, and we can write it as a product of two brackets that we would normally expand. So putting it equal to 0 implies that equals 0, which implies by the Null Factor Law either that is 0 or this is 0. I think we've done it. So this means x is neg 3 or x is neg 2. Hey, how powerful is that? And now, what do you reckon? Well, we didn't have much on this function. It's not in a perfect square form. We can't see its translations very well. But we've now shown that it goes through at neg 2 and neg 3. Hey, it must look something like this. Why come up the top here? Because the x squared is a plus x squared. So we know it is convex. It's concave up, if you like that. And now we can use the x-intercepts. Even though we don't have it as something like, what do we like? We like this form because we can show how to move x squared around the plane. Well, we actually don't have that. You're going to have to wait till the next presentation to find how to get that, as I said before, to get that vertex point. But we could nail this function partially with the x-intercepts. Hey, can you see why we're doing this factorization of a quadratic now? It's pretty powerful stuff. Let's keep going. And here I've got your method. I haven't shown you how to do it at the moment. So how did I do that? I got x squared plus 5x plus 6, and I said I wanted to package it using the reverse of FOIL back to this form. So we said it was first, so how would we have had x squared? It must have been x by x. But how do you work out the numbers in here? They must multiply to give 6. So what do? I wrote down 6 and 1 and 3 and 2. But I spotted that 3 and 2 came to 5. So if I put plus 3 in there and plus 2 in here, that would have given me 6, and also the other products, 2x and 3x, give me 5x. So I've got to do a bit of backwards thinking. I've got to know FOIL very, very well, and then I can do it backwards. So Pearson's here have set up a set of steps. So what are we going to do? We're going to call it the cross method to factorize monic trinomials. In other words, there's only a number 1 in front there. 1x squared. We're not going to do harder ones. So first of all, you put the x and the x from the two brackets. And then you say, which is going to be multiplied by which? So, identify a factor pair. All right, let's do the one I did up here. A factor pair. I could put 6 and 1. To give plus 6x, it would be plus 6 by plus 1, but that would give 7x. Okay, x by 1 is 1x, x by 6 is 6x. So I could put 3 and 2. And 3 times 2 is 6, that checks. And then 3x and 2x is 5x. So let's do it for this next one here. You look at the front term, so that's x and x. So put that down here, come down the bottom. And then you say, let's look at this term, neg 35. Now that could be neg 35 and 1, or neg 7 and 5, or neg 5 and 7, or 7 and neg 5. And neg 1 and 35. All the different combos to give the number 35. You've got to do some multiplications in your head, some times tables here. Now if I use neg 7 and 5, can you see that when you add them up, x times neg 7 is neg 7x, x times 5 is 5x, so that's going to give me over all the x's neg 2x. So this is a little cross-method way of checking which pair to put in the brackets. Now you don't have to use this. Let's do another one. X squared, and let's say it's take 4x, take 12, Okay, and we're going to put equal naught. So we're going to factorise this. So let's just do it this way. You don't have to put the cross in if you don't want to. X by x, why? Because x by x is x squared. Now we want numbers down the end here. 12 is 12 by 1, or 6 by 2, or 3 by 4. What combo of these is most closely linked to neg 4? Can you see it? 6 and 2. Take them away, it gives 4. So let's play. We want neg 12. It's negative. So one of these dudes must be negative. So we could try neg 2 and plus 6. Neg 2 by 6 is neg 12. Yep, that'd work. But look out, neg 2x and 6x is 4x. Uh-oh. That didn't work. We want neg 4x. So let's change it. Let's make the 6 the larger, the negative one, the larger number in size. 6 is negative, so that the negative wins. In the end, you're going to have more negative x's than positives under FOIL. Okay? By the cross method, x and x, and we would go neg 6 and 2. Either way, it doesn't matter, but in your mind, I want you to think of all of this as reverse FOIL. It is not really a new area of mathematics. It's really going backwards. And once we've done that, of course, we can put this function equal to naught and say that therefore x takes 6 is naught, or x plus 2 is naught, and get x is 6, or x is neg 2. And we can actually plot the graph now, based just on where it cuts the x-axis. How powerful is that? Okay, let's go down and have a look. Now there are some easier ones, of course. You know that if you have a squared take b squared, that came from a particular pattern. A plus b by a take b. So you can reverse that. So if I give you hang on, let's do it in x land again. X squared take 4, you would say, hey, honey, that's the difference of 2 squares. It's x squared takes 2 squared. So that should come to x plus 2 by x take 2. So that is a form that it pays you to recognise. A square minus a square. It's called the difference of 2 squares. And the product that produces that is a plus b by a take b. So we can write as a product of factors, which is called factorized form or factored form, quite easily by spotting it. Okay, so that's a little shortcut. What's another one that you're supposed to be able to spot? Most people can't spot this, and that's when you see a square and another square, and the middle term is twice the product. Right, a square and a square, and it could be a negative product in there, then that packages up to a perfect square, a plus b by a plus b. Now, you might not be able to spot that. I'll give you one. X squared plus 6x plus 9. Now, you're supposed to see that that's 3 squared, and that this is 2 by 3 by x. But if you can't spot the perfect square form, you can always FOIL it backwards. Or factorise it using reversal FOIL. X by x is x squared. Factors of 9, 3 and 3. And they'll both be plus. So you get plus 9 and 3x, and 3x is 6x. So you can just use FOIL if you don't think you're able to spot a perfect square form. I think we're ready to have a look at a few examples. And first of all, from Pearson's again here, these methods can be used to solve quadratic equations. First of all, the right-hand side is 0, and you usually work with the expression on the left. Factorise the expression by looking for a common factor. I think we did one before like that. We'll come and look at that again. Or is it a square minus a square? Or a perfect square form? Or is it the reverse of FOIL? A monic trinomial, or sounds important, doesn't it? Trinomial, 3 numbers, x squared, 2x and a number, something like that. And so we can reverse FOIL here. They've got, so the coefficients of the two middle terms multiply to give the constant term. That's reversing FOIL. All right, let's have a look at some examples of this. And there's one here. You may need to take out the coefficient of x squared as a common factor. So something like what? 2x squared, what can we say? Plus 12x, something like that, plus 16 equals 0. You could divide both sides by 2 because it's a common factor. All right, 2 goes into that, and here. All right, so you might divide through by a common factor first, or you could divide both sides by 2. There is what we're saying. And then what is it? X by x to give x squared. Yeah, that checks. Numbers multiply together to give 8. 4 and 2. That's not too bad a one. And if I put plus and plus, it'll give 8. And the middle terms will be 4x. And 2x is 6x, which checks. So you can have a lot of fun. It's rather like a puzzle working backwards here. So see what you think. Let's go and have a look. Here's some more from Pearson's. So these are the ones we were looking at before. X by x take 2 is 0. X plus 1 by x take 6 is 0. Now these are friendly ones because they've already been factorised. So let's come down and have a look at what we say. If we're solving that equation, 0 on the right hand side, it's where the function's cutting the x-axis if you want. So the first one is 0, x is 0, or x take 2 is 0. So there are our two solutions. X take 2 is 0, add 2 to both sides, x must be 2. And you could draw a little graph of that. This is what we were doing before, 0 and 2. And so you could relate it back to the graph of the quadratic function. Gives us a little bit more meaning and importance. This one is also already factorised. 2 factors times together to give 0 by the Null Factor Law. Either the first one is 0 or the second one is 0. So x is neg 1. Subtract 1 from both sides to get x back again. Add 6 to both sides to get x back again. X is 6. And again, if you looked at that original function that factorised to that, let's do it. What is the function? It's x squared take 5x take 6, isn't it? And if you FOIL it out, that would have been the quadratic function, and it goes through at neg 1 and 6. Like this. Hey, we're getting a lot of information here. No battery problem anymore, I don't think. Okay, so let's have a look at question 1. There's question 1. They're already factorised. So I want you to solve the equation, state the two x values. You can draw a little sketch of what the graph might look like as well, if you'd like to. That's a bit of additional information you can put at the end of this question. So pause the presentation. I want you to do all of these, and particularly this last batch, the last 6, I'd like you to try and draw a graph. So say what the function is, y equals. I think you should expand it, get the x squared and the x term and the number down the end, and then draw a little graph so that you can see, you can go back to the original expanded form or to the factored form and see the connection with the graph of a quadratic function. Okay, I'm going to go on now. Let's have a look at some more examples from Pearson's. So these are using our idea of factorisation again. 4x squared equals 0 and x plus 1 squared equals 0. 4x squared equals 0, divide both sides by 4. They haven't put that in there, put it over here. X squared is 0, which means the only thing squared is 0 itself. What about x plus 1 squared is 0? Well, you could say it's x plus 1 by x plus 1. That's what it means. So when is the product 0? When either this factor or this factor is 0 by Null Factor Law. But they're both the same. So it only yields one answer, neg 1. So with this one, would you like to try and draw the graph of this? Well, you already know from before. X squared plus 1. There's x squared. There's x squared. It's not x squared plus 1. It's x plus 1 all squared. Y equals x squared. X plus 1 all squared is a neg 1 translation, isn't it? So you could have worked it out that it was going to be across there, and therefore the x-intercept is x is neg 1, and it's just touching because both the factors are the same. So you'll get the hang of this. When you have this perfect square form here, it's going to be sitting right on the axis. It's going to be touching the x-axis, not cutting it. So have a look at these. Check the answers down below, and for these last three, I would like you to draw the graph. Do it algebraically by multiplying the factors together, null factor law and all that stuff, and then check it with a graph. There's some interesting ones coming up. Let's have a look. Here are the techniques used for the next one from Pearson's Factorize quadratic equations. Take out all common factors, and if there's a negative in front of x squared, put that outside the bracket. We'll do one of those in a minute. Use the difference of two square rules. If you're lucky enough to see that, a square minus a square, or use perfect square rules, or use your method, which is the opposite to FOIL, to actually factorize it. Okay, let's have a look at some examples here. Okay, so here are a couple that aren't factorised. 3x squared takes 6x equals 0, and 11x squared equals x. Okay, so everything across the left-hand side it already is. Now, can you work out something that will go into both of these? Well, 3 does, and x does. So if you put that out the front as a common factor, what do you multiply 3x by to get 3x squared? It's an x. It's the reverse of FOIL. What do you multiply 3x by to get neg 6x? It's neg 2. So we're going to reverse the expansion rules. Expansion is being reversed to get our factors. Okay, then 3x is 0, or x take 2 is 0. So x is 0, or x is 2. So if you tried to draw the graph of 3x squared takes 6x, could you do it? 0 or 2. There's the first one, and over here, there's the other one, and it opens upwards because that's a plus 3. So we actually could draw a little graph for that one. What about 11x squared equals x? Uh-oh, we don't know how to do it unless there's 0 on the right, because we want to use the Null Factor Law. So subtract x from both sides equals 0, and then what goes into both of these terms is an x. And what do you multiply x by to get 11x squared? It's 11x. What do you multiply x by to get neg x? It's neg 1. So reverse the idea of expansion. Package it up. Why? Because then we can say either x is 0 or 11x take 1 is 0. Okay, by the Null Factor Law. So 11x equals 1 or x equals 11th, x equals 0. Okay, why do you think they were such big numbers? Look at it now. If you made the graph before you put equal to 0, and now you're putting it equal to 0, there's x is equal to 0, that's one answer, and x equals 11th. Gee, that's right in there. Gee, that's a steep one. Oh, hey, we knew that. Look, the number in front of x squared is large. That's a real stretch or dilation by a scale factor of 11. Oh, yeah, so that's why this is in tight. That's 1/11th, 0. The x-intercept there is 1/11th. It's all linking up, isn't it? Think about this. You're a budding young mathematician. Who cares about calculators? Okay, let's have another look, another example here. Oh, here's some of might be perfect squares. X squared take 49 is 0. 4x squared equals 25. 5x squared equals 3. First of all, let's get 0 on the right-hand side. That's all right. X squared take 49. So x squared, that's x squared take 7 squared, isn't it? So we can use x plus 7 by x take 7. Therefore, the first factor is 0, or second factor is 0 by the Null Factor Law. So x is neg 7 or 7. And we can do the graph of that one. But we could have done that one already, couldn't we? X squared take 49. That's a y translation of x squared way down here at x squared take 49, neg 49 down there. But what we now know is if you go up there, this will be neg 7 naught, and over on this side 7 naught. Okay, powerful stuff. Okay, what about this one? 4x squared equals 25. Okay, let's put all terms on the left. 4x squared take 25. But can you see 4x squared is 2x all squared? And 25 is 5 squared. So it's a plus b, a take b. So either the first factor is 0 or the second factor is 0 by the Null Factor Law. So, solving this, subtract 5 from both sides and divide by 2. Neg 5 over 2. Add 5 to both sides and divide by 2. Solving an equation. So we have those two again. And this would be a steeper one, wouldn't it? 4x squared take 25. 4x squared is a steep one and down at neg 25. So it's going to look something like this. This be down at neg 25. Remember? A y translation of neg 25, because we're drawing the graph here, of 4x squared take 25. And the equation is where it hits there and there, which is neg 5 over 2 naught and 5 over 2 naught. We're getting a lot of information here about this stuff. Just notice up here, I just want to pause here, we could go across here and divide both sides by 4. There's another way of doing this one. And then if we take the root of both sides, it's plus or minus the root of 24, which x equals plus or minus, root 25 is 5, root 4 is 2. So there's a little tricky-dicky way as well of solving that particular one. Okay. Are you happy? Are you building up a bit of power here? Let's go on. Another example, and then we'll do some. 5x squared equals 3. Okay, so the two ways of doing this, take the 3 across the left, equals 0. And then, this is not really a perfect square, is it? But we can trick it a bit. X squared take root 3 on 5 squared. It's not a perfect square. We can make it a difference of 2 squares though. That's why we often call it dots, difference of 2 squares. There it is. When you square root 3 over 5, you do get 3 over 5. So it's the first one, a plus b, a take b equals 0, and then we can solve this. I've chopped this a bit. X plus root 3 over 5 is 0. X equals neg root 3 over 5, or x take root 3 over 5 is 0. X equals plus root 3 over 5. You get those two solutions. Or do you want to come back up here and say x squared is 3/5, divide both sides by 5. X equals plus or minus root 3 over 5. So it's the same maths really, set out differently. So let's keep going. Let's have a look now, and I want you to try these. Okay, and there's some answers down there. So factorise it, don't look at the answers, and then come down and check it. Maybe draw little graphs of the function to check what you're doing. All right, pause the presentation and have a go. I'm going to go on now, and I'll just show you the rest of the answers there. Okay, there are the total answers. Okay, so mark your work, and on we go. Here's the next type. Oh, here's the big ones, where FOIL's been done. So let's do those. First of all terms to the left is 0. Then what we want is, this is x by x to give x squared. Two numbers multiplied to give 25. 5 and 5. So it's x plus 5 squared equals 0. So x plus 5 is 0. X is neg 5. Draw a little graph. What would it look like? X plus 5 squared would be across here at neg 5. And it would just be touching the axis. Okay, if you drew the graph of y equals x squared plus 10x plus 25. Okay, what about this one? We need to move all terms across to the left to make it equal to 0. Then divide everything by 2, because 2 goes into all of these. Right? So then we have x squared take 18x plus 81, and we could do either perfect square if you've recognised it, or 81 is 9 by 9, but because it's neg 18x in here, it'll be neg and neg. So it gives 2 by x take 9 squared equals 0. So therefore x take 9 squared equals 0, x equals 9. So in other words, if you drew the graph of this, here it'd be 162. If you put that equal to naught, it comes to, well, first of all, it comes to 2 lots of x take 9 squared. So x take 9 goes down here from x squared. It's steeper because of the 2, like that. So this is the graph of 2 times x take 9 squared. And now we know that, oops, hang on, I've got all that wrong, haven't I? Oh, that's not good. I've moved it down instead of across. Let's have a look at this. Oh, here, it's an x translation of plus 9, isn't it? So across here at 9, and where x squared's like that, this is steeper, and it only touches at 9, at the point 9, naught. Oh, nearly made a mistake there. Okay, let's come down, and let's have a look at another one. So there's 3 more here. Okay, these 3, so let's take the first one. Now they've split the term into neg 2 and neg 4. So with the cross method, you would say x neg 2 and the other one neg 4 to give neg 2x, and neg 4x is neg 6x, and then 8 on the end. They've done a method of splitting the middle term into 2 terms that give 8. You can try that, but I think it's better to try the reverse of FOIL. Set up your bracket, x and x, and then what gives 8? Neg 2 by neg 2. Negative by negative is a positive, and these sum to neg 6x. Think that's a good idea? Okay, take the next one, all terms to the left. Always have 0 on the right, so we can use the Null Factor Law. Divide both sides by 2, and we get this. Now, I think you should try the bracket now. At this stage, x by x is x squared. That gives that a tick. 12 is 6 and 2. Or 3 and 4, but 6 and 2 give 4. So, what are we going to put in here? Plus 6 and take 2. One's got to be positive, one's got to be a negative, because this is neg 12 when they multiply together. The positive times the negative is a negative. And the bigger one has to be positive, because 6x take 2x would be 4x. So this is going to take a bit of trial and error now. I'll use the bracket method. They're splitting the term into 2 factors that give 4. And multiply, of course, to give 12. Let's look at the last one. The last one we don't like. Well, then, hang on, we haven't finished this off. Get the product, put the 2 equal to naught, and then draw the graph, neg 6 and 2. So we're down at neg 6, up at 2. So if we would draw the graph of that function before we put it equal to naught, we could say it looked like that. What about this one? Can you see the difference? There's a negative. Well, what we do is to divide that out. Remove the negative, so this would be neg by positive x squared, and negative by positive 4x would give neg 4x, and negative by positive 3 would give neg 3. So actually remove that negative sign first, then you can split the term like they're doing here, or try the brackets, or try the cross method to check out your factors. 2 numbers multiplied together give 3. That's an easy one. 3 and 1. Plus 3 and plus 1. We'll check all the products, it works. Then either come down here now, got that, x plus 1 is naught, or x plus 3 is naught. So x is neg 1 or neg 3. So if you were to try to draw the graph of this one, neg x squared take 4x take 3, be careful, that's a neg x squared. We've got intercepts here at neg 1 and neg 3. But look out, that neg x squared means it's going to go like that. We've still been able to nail the function though, haven't we? Okay, come down. Here's a summary of the methods from Pearson's. Equate one side to 0, take out a common factor, in particular take out a negative, look for the difference of squares or a perfect square. You can split the middle term or reverse, FOIL, or use a cross sort of method to work out the numbers you want up here. And the coefficient of x squared might have to be divided through. So keep those rules in mind. Maybe pause the presentation and note those down as notes. Okay, let's go on and have a look at some problems for yourselves here. 5, 6 and 7. Pause the presentation, and I want you to do most of these and to try to draw a graph in each case. Okay, let's go down and look at the answers now. Well, here are some answers for 5, 6 and 7. There they are. Did you get those? One of each of the types from above. Okay, good luck. Let's go on with more practice now and have a look. Here are some understanding problems, 8, 9 and 10. So pause the presentation and look at the solutions below. Bit more of 10 there. I've split this into sections of difficulty. So here's 8, 9 and 10. Let's go on to the harder ones now. Interesting questions here. 11, 12 and 13. Getting into what's called modelling. Applying mathematics to model or explain a practical situation. Have a go. Let's have a look at the answers. There they are. And we've got a few more here before we finish up. So here's our reasoning questions, 2 of them there with little pictures. This is a modelling where we're using the quadratic function to describe a practical situation, or we model the situation, mathematical modelling, a mathematical description of a practical situation. Okay, let's look at the answers to those then. There we have 14 and 15. And final one, the open-ended questions tend to be a bit more challenging. Oh no, we've still got 16 and 17 before the open-ended ones. More modelling questions, modelling the trajectory of a golf ball and modelling something to do with diagonals in a polygon. Getting harder. Okay, let's look at the answers. Oh no, hang on, we've got to look at the rest of the question here. It's a bit longer than what I thought. 17. Okay, 17 has got a lot happening. That's a challenging one. Okay, and then come down, look at those answers. Quite a bit of work there in 17. Okay, let's look at the final ones now. The open-ended questions. Okay, bit theoretical these. Okay, have a go, and let's look at the answers now to 18, 19 and 20. All right, there they are, just possible answers. There are other ways of looking at them. Check with your teacher. Now, are you excited? Our journey of quadratics has really exploded. We wanted to see what we could do with this interesting function. It can form bridges, forms a McDonald's sign, satellite dishes. We're really learning a lot about it, with and without technology, and now we're using it in modelling. It's an exciting journey. So hang on in there. I hope you're happy with the new skills you're learning. Practice them up. And in the next presentation, we're going to have a look at how to find the vertex of a parabola if your batteries are flat. Hey, that should be good. Cheers for now.